Hello, these are Flip Notes 2.1 in our new unit, Unit 2 on cognition, and we're talking about thinking and problem solving. My Bitmoji is doing some high-level thinking there. Let's get going. So, what is cognition? We know that cognition is a fancy word for thinking, but lots of things count as cognitive processes. Just attention, what we're looking at and thinking about in the present, language, which will be discussed in a future chapter, as well as learning, memory, which is in this section, perception, which we just finished up in our last part, and thought. So all of those count as cognition. Thinking or cognition refers to a process that involves knowing, understanding, remembering, and communicating, all parts of thinking. Metacognition, a big fancy word that means thinking about thinking. So when we're analyzing what we know, what we understand, what we don't understand, planning, all of that is metacognition. And really, this entire unit is metacognition because we are learning and thinking about thinking. Cognitive psychologists kind of break thinking down into a few different things, a few different mental activities, including concepts, problem solving, decision making, and judgment formation. So how do we organize what we think about? We form concepts. So a concept is just a mental grouping of similar objects, events, ideas, or people. So we basically all the things that we know, those are concepts. All the objects, those all count as concepts. And then the details that characterize those concepts are schemas, the list of features of a concept, the characteristics that make the item what it is. So for example, a chair is a chair because it is something that you can sit in. And then a prototype is a typical or best example of a concept that demonstrates the schema. So something that perhaps has legs and a back and a seat, that would fit our prototype for a chair. So the mental grouping of similar objects, events, ideas, or people, again, those are our concepts and our schemas. So there are a variety of chairs, but their common features define the concept of a chair. So these all could be considered chairs. They're all a little bit different, but they fit into that general mold of the concept of a chair. We tend to organize our concepts into hierarchies. So an example of a concept hierarchy, if we looked at animals, we could divide animals to domesticated and wild. Domesticated, ones that are able to be trained and used for work, could be divided into dogs, cats, cows, and then we can divide those even further. So we tend to break up our concepts into hierarchies. We form some concepts with definitions. For example, a triangle has 3 sides. I actually forgot and took that triangle picture off there. But mostly we form concepts with mental images or typical examples, so our prototype. For example, the prototype for a bird is usually when we picture just like a little songbird or a robin. A penguin doesn't really fit the prototype because it doesn't swim, doesn't have the same kind of feathers and body shape. Another example, an ostrich doesn't really fit the prototype. So there's always exceptions to prototypes. What happens when we encounter new information? The terms assimilation and accommodation explain how we add new information into what we already know. So in the picture there, the little girl, she has learned what a doggy is because it looks like her family has their own pet dog. But then she goes somewhere else and she encounters a cat and she calls the cat a doggy. So in this case, these are examples of the terms assimilation and accommodation. So let's break that down a little bit further. So we know schemas are mental molds into which we pour our experiences. So for example, schemas, a ball is something that rolls. A dog is something furry with 4 legs. Grandma could be any older lady. But as we get older, schemas get more specific with experience. So and as children experience new things, they shape their schemas into one of 2 ways. So with assimilation, they interpret the new information in terms of an existing schema. So she sees a zebra. Well, a zebra is a lot like a horse, so she blends that zebra into her existing schema for horse, and that's assimilation. With accommodation, once they start to learn new information, then they adapt their existing schema to incorporate new information. So now she's learned, oh, a zebra has stripes, the horse does not have stripes. So she creates a separate schema for zebra and horse. So back to the little girl example. Her first schema is for a doggy. So she knows a dog is furry and has 4 legs. That's her schema for dog. So when she comes across a cat, well, the cat is furry and has 4 legs. So she assimilates the cat into her schema for dog, and then now she's calling the cat doggy. But as she gets to know the cat a little bit more, maybe her family gets a cat. I guess that's what's happening here. They're getting a cat. She starts to realize the differences between the two and realizes, oh, well, the cat is furry and has 4 legs, but it also meows, and it's just a little bit more temperamental than the dog. So now she has changed her existing schema to adapt to the new information. So that is accommodation. All right, so, there it is here. Assimilation, when she's thinking anything with 4 legs is a doggy, and then accommodation, anything with 4 legs and barks is a doggy. So she had adapted her schema to be more specific. Problem solving. So different problem solving strategies that we'll look at: trial and error, algorithms, and heuristics. Trial and error is the most basic. You're just trying all the possible solutions, throwing out ones that don't work until you find one that does. It's random, haphazard, like you're trying to figure out, what do you want to wear? You go in your closet, you look at all the options, you can use trial and error. An algorithm is usually something we associate with computers because computers use algorithms very quickly. And for us, when we do them manually, are very time consuming. But it's when we consider all the possibilities before arriving at a solution. Computers use algorithms more systematically and less random. But let's say that we want to find, the example I think in the crash course is sriracha, but I'm going to use duck sauce. So duck sauce is like sweet and sour sauce that I would dip foods like egg rolls into. So if I'm at the grocery store and I want to find it using an algorithm, I would start on aisle 1 and look on every single aisle, every single row until I find it. So if I start at the very beginning and I'm looking row to row to row on every single aisle, I will eventually get there. It is very time consuming, but I'm not going to miss it because I'm going down every single row. That's an algorithm. I'm considering all the possible solutions. It's going to take me forever, but I will eventually come across the correct answer. The friendship algorithm comes from the Big Bang Theory, when Sheldon's coming up with ways to make friends. He's a little bit socially awkward. So a heuristic is an alternative to the algorithm. So the heuristic is basically a shortcut, a guiding principle, a rule of thumb. So they allow us to make judgments and solve problems more efficiently. So heuristics are less time consuming, but they can be more error prone than an algorithm. So the algorithm, if we were trying to find the duck sauce, then we were going to look at every single row. The heuristic, I would make a guess. I'd say, well, I think duck sauce, it's something that's like a condiment, so I'm going to check out the ketchup and mustard area. Or if this store has an Asian food aisle, I'm going to just go straight to the Asian aisle and look there. So I go there and maybe it's there, and that was much faster than the algorithm. However, it could be something totally weird, and it could be just like in the olive oil section, which would be weird and wrong. But anyway, so heuristics make it for a faster way to solve a problem, but sometimes they're incorrect. So 2 examples of heuristics that we might use in everyday life are representative heuristics and availability heuristic. With a representative heuristic, you're judging the likelihood of something or of things or objects in terms of how well they represent or match a particular prototype. So let's say we come across a person. You meet a slim, short man who wears glasses. He likes poetry. What do you think his profession would be? This guy in the picture here. Do you think he's more likely to be an Ivy League professor or maybe a truck driver? Well, you look at him and we say, all right, well, he wears glasses. He likes poetry. I think that matches professor. But the probability that he is a truck driver is actually far greater because there's actually very few Ivy League professors. But so he, our prototype is he looks like what we think a professor looks like. But statistically, he's far more likely to be a truck driver. So we could be wrong. Another example of a representative heuristic, you come across somebody and you see this person here and say, all right, who's the criminal? Is he a criminal or is he a librarian? Well, your prototype for a criminal, one, he's already in an orange jumpsuit there, so that may kind of fit your prototype for criminal. He's covered in tattoos, so that may cause you to make a quick judgment. So representative heuristics are not always correct. They're based off of what our prototype is. Stereotypes and bias do fall into representative heuristics. The availability heuristic is when you're making a decision, you're basing it on information that was more recently available to you. So basing the estimated probability of an event on the ease with which relevant examples come to mind. So why does our availability heuristic lead us astray? Because sometimes what stands out in our mind is not always the most correct. Whatever increases the ease of retrieving information increases its perceived availability. So a lot of times when people are asked, what do you think the crime rates are like in your area, they tend to overestimate it. And that's because they hear on the news about crimes, but you don't hear news when there's no crimes. So we have more available to us information about bad things happening than good things happening. The pro of that is it does remind us to be safe. So overestimating the number of violent crimes in an area, but it reminds you to be safe. Another example of an availability heuristic, how recently we have heard about an event, how distinct it is, how correct it is. So let's say you're considering going on vacation to a beach, but you've heard on the news that there were shark attacks at some other beach far away, and that influences your decision. Whether or not it was actually close to you or how often that actually happens, that may be misleading and incorrect to how you make your decision. But availability heuristic, you're basing your decision off of what's most recently available to you. All right, some obstacles in problem solving. So fixation is when we can't solve a problem because we're stuck on seeing things only in one way. So an inability to see a problem from a fresh perspective. So this gives us what's called functional fixedness. So the matchstick problem, how would you arrange matches to form 4 equilateral triangles? So a lot of people would lay them flat on a table and try to figure out, okay, how can I make 4 triangles out of this? And you really can't by laying them flat on a table. The solution involves kind of balancing them more vertically here to get 4. There's 3 there, and then there's the 4th one where it's on the table. But that inability to consider that they could be leaned up against each other, sort of like a tent, is fixation and functional fixedness. When they're overcoming that and they come up with a new way to solve it, that's overcoming functional fixedness. Another classic example that they like to use in psych textbooks is the candle mounting problem. Using these materials, how would you mount the candle on a bulletin board? And a lot of people think, okay, I've got push pins. Maybe if I melt some of the wax and I can tie it to or pin it with the wick. But what's actually involved here is you pin the container, and people don't ever usually consider that. So again, people have a hard time solving these problems because they're fixed on the idea of only using the objects the original way they were designed. So some examples of overcoming functional fixedness. So when you can find a new way to use objects other than how they originally intended. So let's say you're in a dorm in college and you want to heat up hot dogs, but you don't have a microwave. You have a coffee maker. So heating up the water, and it's kind of gross, I think, to put hot dogs in your coffee maker and then drink coffee later. Make sure you rinse it out. But that would be overcoming functional fixedness. This person who's made a boat out of a dining table, and that's actually a rake that they've turned into a jewelry holder. So all of those would be examples of overcoming functional fixedness. Mental set is another barrier. Mental set is when we tend to be stuck in our ways because they worked in the past. Tendency to approach situations in a certain way because that method worked in the past. We just had Thanksgiving, and maybe mom's Thanksgiving turkey is always dry every year. Not that great. She makes it. We love her, but it's dry. So she doesn't ever change her ways because she's always cooked it. People say, oh, it's great. Thanks for making the turkey. So it worked in the past, but it wasn't always the best way. Kind of like some people always save their IVN for the night before. They get it done. It's not great. They get a good grade, but maybe not the best grade, but they're set in their ways. That's a mental set. So the next part, making decisions and forming judgments. We make lots of judgments all the time. A lot of it is based on our intuition and not always using systematic reasoning. Framing is one way that we can be influenced to make a decision based on how information is presented to us. So decisions and judgments can be changed by how you word something. So for example, if you were going to buy ground beef, are you going to buy ground beef that's 25% fat or 75% lean? So how you present it or frame it. If we say the dropout rate of a school district is 3%, people would think, oh my gosh, 3%, that sounds like a lot. Whereas if you frame it and say 97% of students graduate, that sounds a lot better. Examples of this always show up in the news, and this is actually a really old image, but it kind of circled around back to being towards more modern times. But it says Trump disapproval rating up to 63% this week, whereas a different station says Trump approval rating steadfast at 37%, with loyal supporters standing continuously by his side. So it's the same statistic, but it's presented in different ways in order to create a different view of the information. That's framing. Priming is similar in that it can trigger thoughts and affect decisions. So when you expose somebody to one idea and then it triggers another idea, you're essentially priming them to think in a certain way. So let's say you see a picture of money before making a decision might make someone more likely to choose a financially beneficial option. Reading a positive news story could prime someone to rate their overall mood more positively. Hearing words associated with kindness could make someone more inclined to help someone in need. Another example, like if you ever go to restaurants, and guys may never know this, but when you go into the women's bathroom of a restaurant, there are signs that say, if you drink alcohol, it could affect the development of an unborn baby. So seeing that sign causes women to think, and that affects their decision later on of whether or not they're going to drink alcohol. Priming. All right, the gambler's fallacy says there's a false belief that the probability of an event in a random sequence is dependent on preceding events and that your probability will increase every time later that it doesn't happen. So basically, the longer something doesn't happen, you think, oh, it's for sure going to happen soon. Like I've been playing the lottery forever, haven't ever won. I'm due to win the lottery soon. That's not actually true. Another example, a family with 5 boys, mom is pregnant again. They think for sure it's going to be a girl this time, but not necessarily. It's still a 50-50 chance that she's going to have a boy or a girl. It's like if you flip a coin 100 times and the last 10 times were tails, the next time they think, okay, it's for sure going to be heads this time. No, it's still a 50-50 chance that it's going to be heads or tails. So that's the gambler's fallacy. The sunk cost fallacy says that when we're trying to make a decision, like if we want to stop something, we tend not to want to stop doing it because of all the time and money and energy we've already invested in it, even if it's something that's not necessarily for the best of us. I've already lost a lot of money, so I might as well keep playing. Or this movie is terrible, but I might as well finish it. Executive functions, this is a new term to our College Board curriculum this year, are the cognitive processes that allow individuals to generate, organize, plan, and carry out goal-directed behaviors and experience critical thinking. So just any time that you're using your present working thoughts, you're controlling your inhibitions, you're planning, reasoning, that's executive functioning. So basically all your current thoughts. Creativity falls into this category. There's 5 components of things that help boost creativity. Your expertise. The more you actually know and understand something, you can be more creative about it. Your imagination, how whimsical and thought-provoking you are, having an adventuresome personality and be willing to trying new things, having an intrinsic motivation to want to try something new, and then a creative environment. Oh, typo. If other people are encouraging you to try new things, that helps boost creativity. Convergent and divergent thinking are both elements of creativity. With divergent thinking, that's where we're generating many unique, creative, possible ideas, but we are brainstorming. Convergent thinking, I didn't go over the example. So if you're at the stage where you're considering all your possible college options, you're at the divergent thinking stage. But eventually you're going to want to use convergent thinking, and that's where you're narrowing down all the possibilities to pick a single or correct option. So once you finally narrow it down and you decide where you're going to actually go, that's convergent thinking. All right, that's it for 2.1.